Welcome to the next lecture, the continuation of the effects of negative feedback. And the subtopic is regarding the frequency response and bandwidth. Okay, what is the effects of negative feedback on frequency response and bandwidth? So we know that AV is equal to A divided by 1 plus beta A. Likewise, I can write AF mid is equal to A mid divided by 1 plus A mid beta. And I can also write AF low is equal to A low divided by 1 plus A low beta. And I can also write AF high is equal to A high divided by 1 plus A high beta. So from this diagram, so if this is your gain without a feedback, this is your gain. The rose color line indicates the gain with negative feedback. So you can see the gain get reduced. Okay, so if the gain is reduced, we need to find the bandwidth. Okay, if I find the bandwidth, so this f1 and f2 represent the bandwidth. Okay, that is the differentiation of difference of higher frequency minus lower frequency is your bandwidth. So bandwidth bw is equal to f2 minus f1. So without a feedback, the bandwidth value is very low. Okay, after applying the feedback, you can see negative feedback, you can see the bandwidth get increased. Okay, so this is your A midpoint, and this is nothing but A low, and this is nothing but A high. Okay, likewise this is your A mid F, and this is your A low F, and this is your A high F. Okay, so I can write A low F. This is your high pass filter, and this is your low pass filter. Okay, this is due to the low pass filter, and this is due to the high pass filter. So I can write A low is equal to for this green color without feedback, A low is equal to A mid divided by 1 minus J F1 by F. Okay, so F1 is this one by F. Okay, so how this equation came means, I told you this is nothing but a high pass filter. Okay, the high pass filter means it is due to the differentiator. The differentiator circuit diagram look like this. Okay, C and R. So I can write V0 is equal to, applying the voltage divider rule, I can write R into V in divided by R minus J divided by WC. Okay, so if I equate V0 by V in is equal to 1 divided by divide the R by both sides, I will get 1 minus J divided by omega CR. So I can write omega is equal to 2 pi F. Okay, I can write omega is equal to 2 pi F, and so this F1 I can write it as 1 divided by 2 pi RC. So here F1 is nothing but your low frequency, right? So I can term it as FL. So this is how the equation comes. Okay, so I can see V0 by Vn is your voltage gain, that is equal to 1 divided by 1 minus J F1 by F. So this equation came using this derivation. Okay, so next in a similar way I can write, first I am going to substitute this fourth equation in your second equation. Okay, so you can see A low F is equal to A low divided by 1 plus A low beta. Okay, this is your second equation. So I am going to substitute this above equation. A low is equal to fourth equation in the second equation. I will get this. Okay, so if I cross multiply and cancel the denominator, I will get this equation, and I have to multiply and divide the both equation by 1 plus A mid beta. So if I do like this, I can term this f1 divided by 1 plus f1 divided by 1 plus A mid beta is equal to FLF. Okay, so I can redraw like this. I can redraw like I can write it as this. I can write it as A mid f. This is A mid f. Okay, A mid f divided by 1 minus j f 1f divided by f. Okay, so from this I can tell the lower frequency is decreased by the factor of d. So similarly I can write A high is equal to A mid divided by 1 plus j f by fh by this is due to the low pass filter. Okay, low pass filter. So if we solve the low pass filter connection is like this. If you solve this one, like Vi V0 RC, you will get V0 by Va is equal to 1 divided by 1 plus j f by fh. Okay, so where fh is equal to 1 divided by 2 pi RC. So you can solve in the similar way. Okay, so you are going to substitute this fifth equation in the third equation. You will get A f high is equal to A mid divided by 1 plus j f divided by fh divided by 1 plus A mid beta divided by 1 plus j f by fh. Okay, so if this equation goes here and the two denominator cancelled out, so you will get this equation, and here you have to divide and multiply by the factor of 1 plus A mid beta. Okay, you will get this equation. Okay, so I can term this FH F is equal to FH 1 plus A mid beta. Okay, so you can see the higher frequency is increased by the factor of D. Okay, so we know that the beta bandwidth with feedback is equal to FH higher frequency minus lower frequency with feedback. So from the equation I can solve like this. Okay, so from the diagram I can tell the bandwidth with feedback is always greater than, with negative feedback is always greater than the bandwidth without feedback. Okay, so this is all about the frequency response. Okay, the higher frequency is increasing by the factor of d, and lower frequency is decreased by the factor of d, and the bandwidth with feedback is increased by the factor of d. Thank you.